Hello, students. Good afternoon.
Good afternoon, madam.
Right. So, so I waited because today is the first lecture. I waited until the participant count is increasing, but still it's 79. Can't wait more than this. Right. Again, at the beginning of the lecture, again I'm reminding you. Uh, Participation attendance is mandatory for this course also, right? So I think so we are starting first year, second semester, and I think halfway through you will get your exams as also, right? You will find your exams of level one, semester one. Level one, semester one exams in a api level one, semester two start karana, right? So under the level one, semester one, so that means during the previous semester you have experienced two maths courses. One is basic mathematics and the other one is pre-calculus. Right. So with that foundation that you have got, so now you are coming to much more advanced courses on the vectors and matrices, right? So at the matrices also, you have done some parts have been covered by Dr. Lakmini under basic maths, right? Other than that, there are some other parts that we have to cover under this, and also vectors is also here, right? Again, I saw there are now two chat messages are there from two students giving me the attendance. Again, I am reminding you students, please don't send me the attendance at the beginning of the lecture, right? So my rule is same for almost all the courses that I'm teaching, right? So the attendance, if we are doing online lectures, so during my lectures, attendance should be sent when I inform you. මම කිව්වම තමයි ඔයගොල්ලෝ මට attendance එවන්න ඕනේ. Right at the beginning of the lecture, please don't send attendance, and also I'm ignoring those attendance. Right. So this is IA 1204 vectors and matrices. So this is this 15 weeks lecture, totally theory lecture. So altogether 30 hours are there. So that means for a week you have 2 hours. So all 15 weeks you are about to cover 30 hours, 30 lecture hours. So here during this course, so here now you can see the detailed curriculum. The course code is IA 1204, 2 credit course, and there are 30 lectures, no lab practicals, and there are 5 tutorials, right? So during this lecture, so I'm sure I have other than this 30 lecture, most probably I will take some other more hours to conduct the tutorials. So anyway, we have to cover 5 or more tutorials under vectors and matrices, right? So course objectives to construct or give examples of mathematical expressions that involve vectors and matrices, to evaluate mathematical expressions to compute quantities and deal with linear systems and eigenvalue problems. So to apply matrix and vector concepts, model, analyze, solve real-world situations. Right. So the intended learning outcomes are define basic terms and concepts, apply matrix calculus in solving systems of linear algebraic equations, calculate area of planar shapes and the volume of parallelepiped using vector algebra. Right. So under that, these are the course contents. These are the course contents. So by looking at the course contents, you will understand some of the contents that you have already covered under the basic maths, but there are some advanced parts coming under this course, right? So recommended readings are here, right? So here you can see 2 book boons published materials are there. It can be download from the internet, free download from the internet. Other than that, any other material on the Google is valid. So you can find more questions, more examples, more explanations from the internet, and also any other reference books which is relevant to this subject. No limit for that, right? One reference book එකක් මේට අදාළව ඔයගොල්ලන්ට use කරන්න පුළුවන්. එහෙම limitation එකක් නැහැ. Right. So the name of this course, although the name of this course is Vectors and Matrices, right? So vectors come first and matrices as the second, but we are going to start from matrices. That is because one thing is you have already covered some parts under the basic maths. And other than that, so in order to do vector calculations, we need matrices, right? In order to perform some vector calculations, we need matrices. So therefore, first it is advantage, it is definitely learn matrix and then gradually move on to vectors. Okay, so this is the overall curriculum. So with this, during this semester, you will be having another maths course, that is introduction to calculus. So last year I did that course, but from this year onwards, I'm not conducting that course because I had to do programming, introduction to programming from this semester onwards, because the lecturer who did the programming is no more with the department. So therefore, so I had to do that. Therefore, I'm not conducting. There's another new lecturer who's going to conduct introduction to calculus for you. Right. So I think tomorrow you will be having the introduction to computer programming lecture that is also conducted by myself. Right. Right. So here with this detailed curriculum, so we'll move on to the lectures. So the first lecture. Lecture 1, right? The first lecture, basics. So under here, so I will be doing the basics, but most of the basics I'm sure that I'm doing here is should be covered under the basic maths. Basic maths වල කරපු ගොඩක් basics මෙතන දකිවි ඔයගොල්ලෝ. ඊට අමතරව සමහර additional parts, right? Okay, let us consider set of simultaneous equations. I'm sure that you have already given set of simultaneous equations and with the use of Cramer's rule that you have solved the simultaneous equations, right? So before that, so let us consider set of simultaneous equations. Then, so when it comes, so here now we are going to learn about matrix. So the first thing which would come to our mind is, what do you mean by a matrix, right? Then ඔයගොල්ලෝ matrix calculate කරලා තියෙනවා, matrix එක වැඩ කරලා තියෙන නිසා දන්නවා කොටු වරහන් දෙකක් ඇතුලේ තියෙන ඉලක්කම් set එකක්. There are rows are there, columns are there, right? So within sometimes box brackets or within curly brackets, there are some set of numbers. So that is matrix actually, right? So in real world, right? Actually, in real world, so how these metrics are coming up, right? The matrix හැදෙන්නේ කොහොමද? මේ කොටු වරහන් ඇතුළට ඉලක්කම් ගියේ කොහොමද? Right? So this is actually we need to know. නැත්නම් මේක තමයි matrix එක කියනවට වඩා. So rather than saying this is the matrix, right? This is the matrix. මේක තමයි matrix එක, මේක matrix එක විදිහට පිළිගන්න. Right? Accept this as a matrix. This is a matrix. You have to accept this is a matrix. So there is no hard and fast definition is there, right? I'm always telling you, so if you are learning something, try to adapt it to the real world situations, right? Real world applications වලට අදාළ කරගෙන ගෙන ගන්න එතකොට හරි ලේසි. නැතුව මේ 아무තු දේවල් නෙමෙයි, right? So here so consider set of simultaneous equations, right? So here there are 3 simultaneous equations with 4 unknowns, right? 3 simultaneous equations with 4 unknowns, right? So how these simultaneous equations comes up? දැන් මෙතන simultaneous equations කියන මේවා කොහොමද හැදුනේ? Right? So right? According to the applications, you can form set of simultaneous equations. So especially when you are going to the third year, there you will find a course called Applied Numerical Methods. So there, within that course, so we are giving you a practical application. You are the one who should construct equations and you are the one who should solve the equations. ඒ maths course එකේ වෙනස ඒකයි. දැන් මෙතනදී නම් අපි simultaneous equations දීලා ඔයගොල්ලන්ට කියනවානේ. So here we are giving the simultaneous equations and tell you the use of Cramer's rule you have to solve this, right? But within that course, we are not going to tell you, right? These are the simultaneous equations and use the Cramer's rule to solve it, right? There, what we are going to do is we give a practical application and you are the one who should construct the simultaneous equations, right? Then you are the one who should solve it using appropriate method. It can be a traditional method or else it can be Cramer's rule, whatever, right? So, okay. So, in this set of simultaneous equations, there are 3 equations with 4 unknowns. So, what are the unknowns? X, you don't know what is the value of x exactly, y, z, g. So, these are the 4 unknowns and 3 simultaneous equations. So, if we write down the coefficients of x, y, z, t enclosed within the bracket, right? So, what are the coefficients? So, for the x, the coefficient is 1. For the y, coefficient is 2. For the z, 3. For the t, 5. So, those are the coefficients of the first equation. For the second equation, 4 is 4, 2, 5, 7. Right? So, those are the coefficients of the second equation. 5, 4, 2, 6. Those are the coefficients of third equation. Right? So, by using these coefficients, right, by using these coefficients, you will be able to construct a matrix, right? So, if we consider about the first row, first set of coefficients 1, 2, 3, 1, 2, 3, 5, right? So, the coefficients of the second equation 4, 2, 5, 7, and the coefficients of the third equation 5, 4, 2, 6. So, with the use of the coefficients, we have constructed a matrix. The matrix එක කියන්නේ විශේෂ දෙයක් නෙමෙයි. අපි එදිනෙදා පාවිච්චි කරන ගණන් ඇතුළෙම තියෙන දෙයක්. So here you construct a matrix out of the coefficients of the given simultaneous equations. Right. So the system of numbers arranged in a rectangular array in rows and columns bounded by bracket is called a matrix. Right. So it is another representation of numbers. Right. It is another representation of numbers. So here, for example, right. So for this particular first equation, so I can write an array, right? In computer science also we are writing arrays 1, 2, 3, 5. Right. So, right, for this one, 4, 4, 2, 5, 7. Right? This is 5, 4, 2, 6. Right. So if we know only the concept of arrays, right? If we know only the concept of arrays, so we can represent the coefficients of each and every simultaneous equation as in like a individual array. අපි array කියන concept එක විතර නම් ගන්නේ මේ විදිහට අපිට represent කරන්න පුළුවන්. Write the coefficient as a single array. Right? As a single array. But since this is another representation where we can represent almost all these 3 arrays within one represent form. මේ arrays තුන ලියනවා වෙනුවට එක representation format එකක් තියෙනවා that is called matrix. Right? It's again another representation format. Right. So next. So the system of numbers arranged in a rectangular array in rows and columns bounded by bracket is called a matrix. If matrix contains 3 rows and 4 columns, so it can have altogether 12 elements. So if we count, so how many elements are there? So there are 3 rows and 4 columns. So therefore 12 elements are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? Altogether 12 elements. So these 3 number of rows are 3 and number of columns are 4. So that is going to be called as what the dimension of the array. We make it indicate 3 multiplied by 4. So That is what we called as the dimension of the array. So the first representation is for the number of rows. Second representation is for the number of columns. Right. So next, there are various types of arrays are there. Right. Various types of arrays are there. Right. So the first array is a row matrix, column matrix, and null matrix. So here, so why we are learning various type of matrices? Then, so under the basics maths also, so you have done so many calculations. Kuda calculations karna bolo. Kramer's rule dala, simultaneous equations solve karna. You are solving simultaneous equations using Kramer's rule. Then you're finding the inverse. You're finding the minors, coefficients, adjoint matrices. So many things that you are doing. But, right, if I ask to write a row matrix, write a column matrix, then students don't know what do you mean by a row matrix, what do you mean by a column matrix. We would have operations, right? But if I ask you to write down a row matrix with the arbitrary set of numbers, then they are thinking, what is a row matrix, right? So, so the last time past paper, I will available it on the digital library. Then you can access it from the digital library. So there, the very first question is on that. So write down the row matrix, write an arbitrary column matrix, write a upper triangular matrix, write a lower triangular matrix, write an example for the lower triangular matrix, likewise. So those things, so then you should able to clearly write down the row matrix. So when I ask row matrix, some students have written column matrix out of that. Right? So therefore, you will be careful what is row matrix, what is column matrix, and all that. Right? So row matrix is a matrix where there is only one row, right? Where there is only one row, but many columns, right? Eka row ekai තියෙන නම columns ගොඩක් තියෙන පුළුවන්, right? So there's only one row. If it is a column matrix, there is only one column, but there can be many rows. Rows ගොඩක් තියෙන පුළුවන් නමුත් එක column එකයි තියෙන්නේ. Right? Row means only one row, column means only one column. Right? Then null matrix, right? Null matrix means, or else it's called zero matrix. All the elements are zero. Almost all the elements are zero. Right? So this null matrix should not be square matrix. Square matrix null matrix square matrix. Right? So now it's a square matrix. Square matrix means number of rows and the number of columns are equal. Rows columns samana. Right? It can be 3 by 3, 4 by 4, 5 by 5. So anything, right? So I'm saying null matrix is no need to be a square matrix always. So here you will see, so there are 3 rows, 4 columns, 3 by 4. It's not a square matrix. But square matrix is very important because most of the calculation, for most of the calculations, the matrix should be square. So otherwise we can't proceed, right? So next is diagonal matrix, right? So if it is a diagonal matrix, the first necessity is it should be a square matrix. Diagonal matrix එකක් වෙන්නට නම් ඒ අනිවාර්යයෙන්ම square matrix එකක් විය යුතුයි. Right? So that is the first point. Diagonal matrix. To be a diagonal matrix, the first qualification is it should be a square matrix. So then, in order to be a diagonal matrix, almost all non-diagonal elements should be zero. So what is the diagonal here? The diagonal diagonal. Right? This is the diagonal. Right? So other than this diagonal, all non-diagonal elements, there are diagonal elements. Right? So almost all these non-diagonal elements, almost all these non-diagonal elements should be zero. So that is called it as diagonal matrix. Diagonal එකේ නොපිහිටන අනිත් සියලුම elements ඔක්කොම බිඳුව වෙන්නට ඕන. මේ විදිහට. Right? Okay. Right. So, right. Unity or identity matrix. Right? Unity or identity matrix. So for that one also, in order to be a unit or an identity matrix, it should be a square matrix. First qualification is square matrix. So that's why I told you square matrices are very important, right? Unit or identity matrix should be a square matrix. Then all diagonal elements are unity, right? All diagonal elements should be 1. And also, almost all non-diagonal elements are 0. Right? අපි පුරුද්දට 3 by 3, 2 by 2, 2 by 2, 3 by 3, 4 by 4 unit matrices ලිව්වට, right? So we don't feel these properties. It should be a square matrix. All diagonal elements are 1. So we know that. And all non-diagonal elements are 0. So that is called unit to identity. Right. So next one is transpose of a matrix. Right. So what do you mean by transpose of a matrix? You already know. So how to perform the transpose of a matrix? We have to interchange the rows and the columns. Right? By interchanging rows and the columns, we will be able to transpose the matrix. So if we ask to write down the transpose of the matrix A, the first thing is the symbol. Right? So make transpose which a matrix can indicate the symbol A to the power capital T. And in some references books, they are using A to the power something like this. So dash, capital I can be considered like this. But anyway, these two symbols are using to indicate the transpose matrix, right? So by the way, if we have like this is something different. It is inverse. But if we just have a line, right? If we just have a straight line as a power, so then it indicates as a transpose. Some reference books they use T, right? But in some reference books they use this. So normally this is misleading when you compare this with the inverse. But for the inverse specifically, there is like this. But here, if you have just a straight line as a power, so that is also indicated as a transpose. So here, 1, 2, 3 is indicating here 1, 2, 3, 4, 5, 4, 2, 5, 4, 2, 5. So that means almost all the rows has been interchanged to columns and columns interchanged to rows. Right. So next one is symmetric matrix. So what do you mean by symmetric matrix? Right. Symmetric matrix is like this, right? So other than this diagonal elements, right? Other than this diagonal elements, so the non-diagonal elements, there is some symmetry. H, G, G, F, F. Right? So that means other than the diagonal elements, right, there is symmetry in between these two elements. So this is called the symmetric matrix. So if you are given a matrix, right, if you are given in an exam paper or an assignment, if you are given a matrix, and so there can be a question like, check whether this given matrix is symmetric or not. I'm going to give a symmetric matrix, make a symmetric, then check around. Right? So you can manually check this, right? You're going to manually make a check around. But if you are asked to prove that whether this particular matrix is symmetric or not, what you have to do is this. You're going to make a manually check around. Right? So if you want to scientifically prove, mathematically prove that this particular matrix is symmetric or not, this is the operation that you have to perform. So you have A, then what you have to do is you find A transpose, right? You have the original A matrix, then you, next thing is you find the transpose. You get the transpose of the given matrix. Then you can compare both A matrix and the transpose matrix, both are same. So then you can write down, because of A equals A transpose, therefore we can write down that this matrix is a symmetric matrix, right? Right. So that is about the symmetricity. Then next comes is skew symmetric matrix, right? Skew symmetric matrix. So the difference is the minus. So when compared with this one, the difference is minus. H minus H, right? So the negative partner, right? G minus G, F minus F. So skew symmetric matrix is again a square matrix where A transpose is equal not to A but to minus A, right? Not to A but minus A. Definitely within your final paper. So this concept of symmetric and skew symmetricity is there, right? This concept is being shared. So the different types of questions can be given under the symmetric and skew symmetric matrix category. So therefore, you should have to have this knowledge with you. So that means this shows the symmetricity, while this shows the skew symmetricity. Or skew symmetric if you ask to prove that this particular given matrix is skew symmetric, then you have to do these two. You have next you can get the transpose of A, and then you can find minus A, then you can compare and contrast A transpose and minus A, and then by comparing you can say these two matrices are equal. This is a skew symmetric matrix, right? So next one is triangular matrix, right? Triangular matrix. So the first qualification to be a triangular matrix is again a square matrix, right? It's again a square matrix. That's square matrix. So under the triangular matrix, there are two types of triangular matrix: upper triangular matrix and lower triangular matrix. Upper triangular theta, lower triangular theta. Right. So if it is the upper triangular matrix, if it is upper, right, and if it is lower, what is the difference? Right. So other than the diagonal, right? Other than the diagonal, if it is upper triangular matrix, the non-diagonal, or else we are saying off-diagonal elements below the diagonal is going to be 0, right? Eka upper nama, almost all non-diagonal or off-diagonal elements below the diagonal. Diagonal එකට යටින් තියෙන ඔක්කොම non-diagonal elements ටික විහිදුවා. Right? If it is a lower triangular matrix, almost all the non-diagonal elements above the diagonal are going to be 0. So this. Next, complex conjugate, right? Complex conjugate. Now you have done. So now you have the knowledge with you regarding the complex numbers, because you have covered the complex number part on the pre-calculus. So complex conjugate of a matrices. So you know what is complex conjugate. So if the complex number is x plus iy or a plus ib, you know the conjugate is a minus ib. You change only the sign compared to the imaginary part. Right? Imaginary part के sign එක විතරයි මාරු කරන්නේ conjugate එක හදන්න. Right? So that is also applicable to the matrices as well, to the elements of the matrices as well, right? Complex conjugates of matrices. So there we learn about just complex conjugates of complex numbers. So here we are going to apply what we have learned to the matrices. So complex, if complex number is a plus ib, then complex conjugate is a minus ib. So how you're going to adapt that to the matrices? Matrices the main original matrix. So here the difference when compared with the elements which we have previously studied, the difference in this matrix is almost all the elements are complex numbers. And calling up real numbers, so previous we have real numbers as our elements, but here now elements are complex numbers. So we are asked to find the complex conjugates of the matrices, right? Complex conjugate of a matrices. So in order to convert or find the complex conjugate of the matrices, what we are going to do, we change only the sign of the imaginary part. So 2 plus 3i is 2 minus 3i, I minus I, 6 minus 4i, 6 plus 4i, 7, there is no change because there is only real part is there. 2 minus 3i, 2 plus 3i minus I. So that is the complex conjugate of a matrix. Right. So then complex conjugates of a matrices. So here this is the original matrix and this is the complex conjugate. matrix with the complex conjugates, right? So next what we have done is how to find a conjugate transpose, right? We know how to get the transpose. We just need to exchange rows to columns or columns to rows. So that is how we are constructing the transpose. Transpose adagane rows columns or the marble at the columns rows or the marble. Right. Then so if it is a matrix consists of complex numbers, so here that is the matrix, this is the matrix, this is the original matrix. Next we have found out the complex conjugate, then conjugate transpose. So what do you mean by conjugate transpose? Means so after converting to the complex conjugate, that is going to be transpose. Not the original matrix we have to transpose, but first out of the original matrix we need to find the complex conjugate. Then we are getting the transpose. Conjugate එක හොයලයි transpose එකට යන්නේ. So that means we are interchanging the rows and the columns. Right. So if you are asked to find a conjugate transpose, so that means within that question you have to first find the conjugate, then you have to do the transpose. Two operations are involved. Right. If you ask to find the conjugate transpose, first you need to get the conjugate, then you have to do the transpose of the conjugate matrix. All right. So the next thing is these are not right. So here, if we consider about the dimensions, here what is the dimension here? 2 by 3. And here the dimension is again 2 by 3. Right. So since you have done matrix multiplication under the basic maths, so are we? Is there any possibility to multiply original matrix with the complex conjugate? Can we perform multiplication in between these two? Original matrix multiplied by complex conjugate. Can we do that?
We can't, ma'am.
Can't. Why?
Because here the 2 and 3
are not identical, right? In order to perform the calculation, in order to perform the multiplication, so here this is 2 by 3. So again, we need to multiply 2 by 3 and 2 by 3, right? So in order to, if it is, we need to multiply two matrices. So the number of columns should be equal to number of rows, right? So here that is not, these two are not identical, so we can't perform the multiplication in between these two matrices, right? So but here, so we have the original matrix, right? So now, so out of the original matrix, we have constructed the complex conjugate, right? Then out of the complex conjugate, we have calculate the conjugate transpose, right? So then here, so this is but this is 3 by 2, right? So although we can't multiply original matrix with the complex conjugate because both are 2 by 3, 2 by 3, so the number of columns is not matched with the number of rows, but we can perform the multiplication in between original matrix and the conjugate transpose, right? Original matrix and the conjugate transpose can be multiplied because this is 2 by 3 and the other one is 3 by 2. So that so this multiplication is allowed. Right. So why we check whether whether these matrices can be multiplied or not? අපි check කරේ අතරම. So in order to learn a property of to check the properties of Hermitian matrices, right? Hermitian matrices. So properties of Hermitian matrices, if it is a Hermitian matrix, right? If it is a Hermitian matrix, so then M to the power capital H. This indicates the Hermitian matrix. So Hermitian matrix is going to be equal to M. So that means the original matrix, right? Hermitian matrix is going to be equal to the original matrix. So here M is 2, I minus 1, I plus 1, 3. So we can get the complex conjugate to, so here I minus 1, I plus 1, I plus 1, I minus 1 and 3. So if we transpose, right, if we transpose, so this is here you identify it's a square matrix again. This M is a square matrix. So we get the complex conjugate, then we get the conjugate transpose. So here you will observe that, right? You will observe that. So the conjugate transpose, right? Conjugate transpose is again equal to the original M matrix. Original matrix එකම conjugate transpose එකට සමාන වෙලා තියෙනවා. මෙන්න මේ වගේ matrices වලට අපි කියනවා Hermitian matrix එකක් කියලා. Right? So these kind of matrix can be considered as a Hermitian matrix. Same as there. So next is unitary matrix. Right? So what do you mean by unitary matrix? Right? So these are the properties of unitary matrix, right? Orthogonal real and unitary complex, right? Orthogonal. If there is a matrix, and in a question, if you ask to check whether this matrix is orthogonal or not, this is what you have to perform, right? This is what සාමාන්‍යයෙන් මේ unitary matrix අපි unitary matrix කියන එක අපි වැඩ කරන්නේ real numbers එක්ක නම්. If we are working with real numbers, so then there we check a property called orthogonality. Real numbers එක්ක තියෙන matrix එකක නම් අපි check කරන්නේ orthogonality කියලා දෙයක්. Right? The concept of orthogonality is coming with the real numbers. Right? But if we are dealing with a matrix which consists of complex numbers, there we check the property called unitary. Right? For example, right? For example, we will be given a matrix like this. Matrix check whether this matrix is orthogonal or not. Complex numbers. So if the matrix consists of complex numbers, we are checking the unitary, right? The nature of unitary. But for the matrix consists of real numbers, right? If the matrix consists of real numbers, we can say check whether the matrix is orthogonal or not, right? So you will be, so later on you will get a questions like this, right? You will be given a matrix and ask you to check whether this matrix is orthogonal or not, right? දීලා තියෙන matrix එකක් orthogonal ද නැද්ද කියලා check කරන්න. So then what you have to perform is this one. This one. This is again a common question in your final exam, right? To check the orthogonality of a question, given matrix, you need to perform this, right? So assume that you are given a matrix A, then first you need to find the transpose, then separately you need to find the inverse, right? If the transpose matrix is equal to the inverse matrix, right? If the transpose matrix is equal to the inverse matrix, so then we can say that matrix is orthogonal. Matrix is orthogonal, right? So under the unitary case, so unitary means we are dealing with the complex numbers. So there, if the conjugate transpose, now you know how to get the conjugate transpose. Conjugate transpose එකටම තමයි මේ Hermitian matrix එක කියලා කිව්වේ. Again, if I go back, right? Hermitian matrix එක කියලා කියන්නේ conjugate එකේ transpose එකට. Right? Conjugate transpose is what you mean by Hermitian, right? What do you mean by Hermitian? Right? Hermitian. So conjugate transpose. So here you can see the conjugate transpose is indicated as u to the power capital H. That means Hermitian. conjugate transpose කිව්වොත් Hermitian matrix කිව්වොත් දෙකම එකයි. Right? So if the conjugate transpose is equal to the inverse of that particular matrix, so then we are say that particular matrix is unitary matrix. Right? That particular matrix is unitary matrix. Right. Okay, so here another property is if you are going to multiply Hermitian, right, Hermitian matrix with its original matrix, then you will end up with a identity matrix. මේකත් තව property එක Hermitian matrix එක යම්කිසි matrix එකක Hermitian matrix එක ඒකෙම original matrix එකත් එක්ක multiply කරොත් ඔයා end වෙන්නේ identity matrix එකත් එක්ක. Right? So you will be end up with identity matrix. Right? You will be end up with identity matrix. ඒක වෙන්නේ කොහොමද කියලා මම මෙතනින් ඔයගොල්ලන්ට පෙන්නුවොත්. So here you can see u to the power h. If it is a unitary matrix, u to the Hermitian matrix is going to be equal to inverse matrix. එතකොට u to the power h මේක ස්පේස් තියලා ලියනවා. u inverse මේක තමයි ඔයගොල්ලන්ට දීලා තියෙන property එක. unitary නම් මෙහෙම වෙන්න ඕන. මම මේක දෙපැත්තම so I'm going to multiply both side of this equation with u. u වලින් ගුණ කරනවා. Right. So here Hermitian matrix multiplied by u is equal u inverse matrix multiplied by u. So here what is this equal to? මේ multiplication එක අවසානයේ equal වෙන්නේ මොකටද? Anyone? Inverse එක යම්කිසි matrix එකක් තමන්ගේ inverse එකෙන් ගුණ කරාම එන උත්තරය මොකක්ද?
Identity matrix.
Identity matrix. Right? So this is going to be equal to identity matrix. ඒක තමයි මේ මෙතන වෙලා තියෙන්නේ. මෙතන උනේ right? So when the Hermitian matrix is multiplied by its own matrix, so that is going to be going to give us identity matrix. ඒ දේ උනේ මෙහෙම. Right? So if you can remember these properties, it's good because it will be easy for you, especially for the MCQs. Right. Then conjugate of a matrix we know. Square matrix where? Yes. Unitary. So again, this one. Hermitian. Right. So after that, this one. Equal matrices. Right. I'm sure that you have learned equal matrices under the basic maths. Make up. Right. How to check the equality of two matrices. Right. How to check the equality of two matrices. Right. So the first thing should be they should be in same order. Matrices දෙකක් සමානද නැද්ද කියලා බලන එකේ පළවෙනි පියවර තමයි they should be in same order. If this is 3 by 3, this should be 3 by 3. If this is 4 by 4, this should be 4 by 4. And also this can be 2 by 3. No need to be equal matrix. They do not need to be square matrix. Equal when a square when a more net. So if this is 2 by 3 matrix, this should be 2 by 3 matrix, right? Square. In order to be equal, no need to be square. Matrix එකක් සමාන වෙන අනිවාර්යෙන් square විය යුතු නැහැ, right? So the first thing is they should be in same order. Order එක dimensional එක that should be same. So the next one is elements in the corresponding positions are equal. A අදාළ තැන තියෙන elements දෙක සමාන වෙනවා. For example here, so row 1 column 1 එකේ ඉන්නේ 1. So here row 1 column 1 1. Row 2 row 1 column 2 2. Row 1 column 2 2. Likewise, so each and every position So the respective element should be same. So for example, if this is 2 and if the last element is 3, right, these two matrices are not equal. At least if one element violates, right, if one element violates this condition, element එක හරි මේ condition එක violate කරොත් මේක සමාන matrix එකක් වෙන්නේ. Right, so in order to be an equal matrix, first thing is this order should be same, and the other one is corresponding position should be equal. Elements in the corresponding position should be equal. So with the knowledge of the equality of two matrices, you can find the value of x, y, and a. So tell me what is x, what is y, and what is a. What is x, what is y, and what is a?
X is -3. Then what is y? What is a? Y is equal to -2.
Y is equal to -2. Z is there, A is there. Z හොයන්නත් ඕනේ, A හොයන්නත් ඕනේ.
A is equal to 3.
A is equal to 3, then Z is equal to?
Z is equal to 4.
Z is equal to 4. So how to find? Basically, it's very so easy, because based on the knowledge that you are having regarding the equal matrices, so the first thing is they should be have same order. If you check these two matrices, yes, this is 2 by 2 matrix, this is again 2 by 2, so then that is okay. So then elements in the corresponding positions should be same. So that is the next requirement to be an equal matrix. So here, if the elements, so they are saying these two matrices are equal. Right? We do not need to find, they are saying these are equal. If these two matrices are equal, then find what is x, y, z, and a. Right? So then, if the respective elements are equal, x plus 3 should be equal to 0, 2y plus x should be equal to -7, z minus 1 should be equal to 3, and 4a minus 6 should be equal to 2a. Right? X plus 3 should be equal to 0. So that means x equal -3. So then z minus 1 is going to be equal 3. So then z is equal 4. Right. Then 4a minus 6 is going to be equal to a. So then 2a is equal 6. So then a is equal 3. Right. 2y plus x, we know x is -3. So then -3 is going to be equal -7. So then 2y is going to be equal -4. Then y is equal. This is how. So based on depending on the property of equality, we have found what is x, z, a, and y. Right. Then addition of matrices. Right, addition of matrices. If A, B are of same order, then their sum A plus B sum of corresponding elements of A and B. So in order to add or subtract, right? So with the addition, I'm telling you about the subtract also. If we want to add or subtract two matrices, matrices දෙකක් එකතු කරන්න හෝ අඩු කරන්න ඕන නම්, right, the first requirement should be they should be in same order. අනිවාර්යයෙන්ම order එක සමාන වෙන්න ඕන. They do not need to be square. Square විය යුතු නැහැ. But they should be in same order. Right? They should be in same order. Then if those two matrices are in same order, so here this is A is 3 by 3 matrix and B is again 3 by 3 matrix. A is a 3 by 3 matrix, B is again a 3 by 3 matrix. Then we are going to add these two matrices. So then we need to add the elements in the corresponding position. අදාළ position එකේ ඉන්න කෙනාව තමයි add කරන්නේ. 1 plus 4 is going to be equal 5, 2 plus 2, 4, 3 plus 5, 8. Likewise, we need to perform the other additions as well. So this is same for both addition and subtraction. Right. Properties of matrix addition. Right. Properties of matrix addition. So only the matrix of the same order can be added or subtracted. Add කරන්න subtract කරන්න පුළුවන් වෙන්නේ එකම order එක විතරයි. Then commutative law is there. For the matrix addition, commutative law is there. What do you mean by commutative law? Commutative law එක කියන්නේ A ධන B වල උත්තරේම තමයි B ධන එකත් එන්නේ. So you know, so there is one operation under the matrix which violates the commutative law. What is that? Commutative law එක violate කරන එක operation matrix operation එකක් තියෙනවා මොකක්ද? What is the operation which violates the commutative law of matrices?
Products.
Products. Yes, product. So because under the products, right, under multiplication, A multiplied by B is not equal to B multiplied by A. Right. So that is one such place where the commutative law violates. Right. Commutative law එක violate කරන තැනක් තමයි ඒක. So therefore, but for the addition, for the subtraction, commutative law holds. Right. Commutative law එක associative law එක ප්‍රශ්නයක් නැතුව apply කරන්න පුළුවන් for the matrix addition and also for the matrix subtraction. Right. For both matrix addition and subtraction, we can address commutative and associative law. So when it comes to associative law, there are more than two matrices are coming. So the addition of B plus C added to A, here addition of A plus B added to C. So anyway, both sides are equal. Subtraction also same scenario. Scalar multiple of a matrix. Right? Scalar multiple of a matrix. So under the scalar multiple means you're going to multiply a given matrix with a scalar. Right? So here there are two types of multiplication under the matrix. Scalar multiplication is there. Multiplication between matrices are also there. So here I'm talking about the scalar multiple. Matrix දෙකක ගුණිතය වෙනයි, scalar multiplication එක වෙනයි. Right? So under the scalar multiplication, අපි සම්පූර්ණ matrix එකේ හැම element එකක්ම එකම scale එකකින් වැඩි කරනවා. Scalar means the number 1, 2, 3, 4. It's not a matrix again, but it's just a number, real number. Or it can be imaginary number as well. Right? That is called as a scalar multiple of a matrix. So here A is given. Now you are asked to find 3A. Right? Now you are asked to find 3A. In order to find 3A, you should multiply each and every element. So here you have 9 elements. So you need to multiply each and every 9 element with 3. Right here 3, 6, 9, 12, 6, 15, 9, 12, 6. So you need to multiply every element. Hammer matrix ke hammer element ekakma a scale එකකින් වැඩි කරන්න ඕන. So next we are coming to the multiplication. Right? Next we are coming to the matrix multiplication. So product of A and B is possible if number of columns of A is equal to the number of rows in B. So the multiplication එක අපිට කරන්න පුළුවන් වෙන්නේ, as I told you, if the number of columns of the first matrix should be equal to the number of columns of the rows of the second matrix. Right? Right. So the properties of matrix multiplication here. The matrix multiplication is not commutative. Right? Matrix multiplication is not commutative. Associative if conformability is assured. Associative කියන එකත් condition එකක් උඩ තමයි තියෙන්නේ. Distributive with respect to addition, but here මෙතන මේ තියෙන properties වලින් you need to be very concerned with this one. මේක තමයි හොඳටම concern වෙන්න ඕනේ property එක. So other than that, multiplication by unit matrix. So if any matrix is going to be multiplied by unit matrix, so then you will be come across the same matrix. ඕනම matrix එකක් එයාගේ unit matrix එකෙන් වැඩි කරොත් එයාගේ කියන්නේ, so for example the same dimension should be, so we know that if it is a unit matrix, right, it is definitely a square matrix. Unit matrix එකක් නම් square matrix එකක් විය යුතුයි. Right, can be 2 by 2, 3 by 3, or 4 by 4. Then definitely, if you want to multiply a particular matrix with the identity matrix or unit matrix, then definitely the matrix which you want to multiply should be also the square. එකත් අනිවාර්යයෙන්ම square වෙන්න ඕනේ. එහෙම නැතුව අපිට multiply කරන්න බෑ. Right. So and the other one is inverse of matrix exists. Right. So this thing will come later. With determinant. So you know determinant. So then you can just want inverse of matrix exist if the determinant is not equal 0. So මට මුල් ගන්න property එක determinant එක බිඳුව නොවන අවස්ථාවක විතරයි අපිට inverse එකක් හොයන්න පුළුවන්. Right? We will be able to find inverse only if the determinant is not equal to 0. So can you explain me why? Anyone? Why? Right? Anyone? Can you explain why the determinant should not be equal to 0 for the existence of an inverse of a given matrix? දීලා තියෙන matrix එකක inverse එකක් තියෙන determinant එක බිඳුවට අසමාන සමාන නොවිය යුත්තේ. Anyone? So how did you calculate inverse? There are a lot of methods where you can calculate inverse, but under the basic maths, what is the procedure that you have gone through in order to calculate the inverse? Inverse එක හොයන්න පාවිච්චි කරපු method එක මොකක්ද? Anyone? What is the method that you have undergone to calculate the inverse of a matrix?
A inverse is equal to adjoint A over determinant A.
Sorry? What?
A inverse is equal to adjoint A over determinant A.
Mother. Yes. Yeah. So normally we find inverse by how? We divide adjoint with the determinant. Inverse එක හොයන්න මොකද කරේ? Adjoint matrix එක හොයලා තමයි determinant එකක් බෙදුවේ. Right? So adjoint, I write it like this. Assume that we have a matrix called A. හිතමු අපේ matrix එකක් තියෙනවා A කියලා. So then inverse කියනවා මට symbol එක නිසා inverse A is going to be equal adjoint A divided by determinant A. Right? So if our determinant becomes 0, right? If our determinant becomes 0, right? So this determinant can be indicated as, if our determinant becomes 0, what will happen? After determinant එක බිඳුව වුණොත්, yes?
Infinity.
Infinity, right? So that means we can't find an inverse, right? We can't find an inverse. So that's why they are saying, right? That's why they are saying inverse of a matrix exists if determinant is not equal 0. ඒකයි යා කියන්නේ determinant එක බිඳුවට අසමාන නොවිය යුතුයි inverse A කියන්නේ inverse එකේ පදත්තට. Right. So with that, And another property is, right, another property that they given is, if A, if there's a matrix called A, and if we multiply that particular matrix from its inverse, right, from its inverse, then definitely we'll end up with unit matrix. දීලා තියෙන matrix එකක් එයාගේ inverse එකක් වැඩි කරොත් අපිට ලැබෙන unit matrix එකක්. We multiply the given in matrix with its own inverse, then we will be getting identity matrix, right? And here you will see a special property here. And then you will especially observe karanoni. So we normally say A multiply B and B multiply A is not equal, right? But here this is equal. A times A inverse is equal A inverse times A, because in both cases we will be getting identity matrix. මේ අවස්ථාව හැර. So except this situation, for almost all the things, this is true, right? If B is A inverse, then here again A times A inverse equals A inverse times A, because in both cases it will be going to give us identity matrix as the solution. Right. Solution එක විදියට දෙන්නේ identity matrix එක. ඒ නිසා මෙතනට commutative property එක hold වෙනවා. If B is A inverse. Now, right. So this is the only place where commutative exists. Right. Obtain A, B, and B, A. So, right. So can you please tell me, so since you have done matrix multiplication, so what is the answer of AB? What is the answer of AB? How to calculate AB? A multiplied by B. So first thing, so is it, can we do the multiplication between A and B? AB?
Yes, sir.
Yes. If so, then tell me the answer. So you have done matrix multiplication under basic mathematics. Am I correct?
Yes, ma'am.
Yes, right. So then what is AB? I believe that you can remember how to perform the matrix multiplication, right? So if you are going to perform A multiplied by B, so we said, yes, we can perform. Why? The number of columns here is equal to number of rows, right? Okay, I got the, yes, everyone can see one answer is given, right? So if there are different answers, you can send your answer as well, right? So here, so definitely we can perform the multiplication between A and B. Why? Because the number of rows is going to be equal to number of columns. So then what is the, so before doing, so if you are new to the multiplication, what I am always telling you is to determine, before doing the multiplication, first determine what is the dimension of the resultant matrix or the outcome. ඔගොල්ලන්ට එන උත්තරේ dimension එක හිතන්න. කොහොමද dimension එක ගන්නෙ? So 3 by 2. So here we remove number of columns and number of rows. So what is left? 3 by 2. So your result, the dimension of your resultant matrix is 3 by 2. Right? So if you are new to the matrix multiplication, this is the correct way, or this is the error-free way of doing multiplication. Multiplication එක කරන්න පුළුවන් errors අඩුම විදිය තමයි මම මේ කියන්නේ. Right? So here first thing is you determine what is the dimension of your output. Output එකේ dimension එක හිතනවා. So that means there are 3 rows and 2 columns. 3 rows and 2 columns. So altogether there should be 6 elements. Elements have two. So now you mark the 6 vacant positions. Elements height is then height. Right? So first thing is, first you get the first row. Next you get the first column. Right? First row and first column. Right. So then now you are going to do the multiplication. 4 times 1, 4. 2 times 4, 4 times 1. Then next element, 2 times 4. 2 times 4 means 8. 8. So in between plus. Okay. About my writing. So in between plus. Right. So then 5 times 3, 15. 15. Now first position is already filled. Then පළවෙනි හිස්තැන අපි fill කරලා ඉවරයි. Right? So the next thing is, right? So this is the next position. In order to calculate the next position with the same row, මේ පළවෙනි row එකත් එක්කම අපි ගන්නවා දෙවෙනි matrix එකේ දෙවෙනි column එක. Right? So we removing this column. අපි මේ column එක අමතක කරනවා. So how to fill this vacant position? මේක fill කරන්නයි අපි යන්නේ. 4 times 2, 8. 2 times 2, 4. Right? 5 times 4, 20. So in between මේ අතර දන්න ලකුණ තියෙනවා. Right? Right. So then now the second vacant position also filled. Right? So now the first row is over. Then first row එකකින් ගන්න ඕන ඔක්කොම වැඩ ටික අපි අරන් ඉවරයි. Now we are going to the second row. යනවා second row එකට. Second row එකත් එක්ක අපේ first column එක. So this one. Right? So delete කරොත් මගේ ඉලක්කම් ටික යනවා ඒකයි ප්‍රශ්නේ. Right? So here anyway. Anyway, so here 27, it is 32. But otherwise it's not clear for you. Right. So next thing, in order to, this is 27, I guess. Then have it 32. Right. So in order to fill these two positions with the second row, first we consider the first column. Right. 3 times 1, it is 3. Then 1 times 4, it is 4. 1 times 3, it is 3. Right? So plus points are there. Right. So excuse me, I'm getting. Right. So now, so this position is okay. So in order to fill this position, now we forget about this. We consider about this column, right? So with this column, with this row, with this column, 2 times 3, 6. 6. Then 1 times 2, 2. Then 1 times 4, 4. Right? So that is, so now already 4 positions have been filled with, so now the second row is over. With the final row, we are doing the same thing in order to fill this particular position with the final row first column, in order to fill the last position with the final row second column. So that is how we are doing matrix multiplication. Again, I am telling, if you are new to matrix multiplication, so doing this, the first you draw the true brackets and then you write down the dimensionality of the output. Selama determine කරන්න output එකේ dimension එක මොකක්ද? And with that you can conclude how many number of elements are there and the placements of elements, whether it's 3 rows, 2 columns, or 2 rows, 3 columns, or whatever. Then you draw the vacant positions there, and by performing like this stepwise, you will able to do the multiplication, right? So it is very important, right, doing, because if you assume that the correct multiplication, the correct addition is important, because if you have missed something anywhere, that means, so it will be problem for you, right? So because for this question, that is only for multiplication. The only thing that you have to do is the multiplication. But so when you go throughout this course, later so multiplication is only one part of a question, right? The මෙතනදී ප්‍රශ්නෙම multiply කරන්න කියන එක විතරයි. So when you go at the end of the lecture, there you have to do You need to diagonalize the matrices. You need to get the powers of matrices. ඒ දේවල් කරන්න යද්දී ඒ ලොකු procedure එකක් ඇතුලේ multiplication කියන්නේ එක step එකක් විතරයි. So if you have done any mistake in the multiplication, that will affect to the whole process. සම්පූර්ණ ගානටම affect වෙනවා. So therefore, correct multiplication is important. Remember that you will be not given calculators for this course. So you are the one who should perform manually. You need to perform manual multiplication. Okay, right. So this is for the students who are new to the multiplication. And then ගොඩක් අය multiplication thoroughly කරලා ඇති. But for those who can't proceed with the multiplication, those steps I think will be used. Next is inverse. Right? If B and A are two square matrices, right, of the same order, right? So AB equals BA equals I. So that means here B is the inverse, right? The commutative property ka hold when hikamatana. So if you multiply a matrix with its own inverse, right? If we multiply a matrix with its own inverse, so then you will get the identity matrix as the result, right? Identity matrix as the result here. So here I'm not going to perform the inverse. Later on, I'll show you how to perform the A inverse. That means how to do the inverse step by step, because now you know so in order to perform the inverse, what you have to do is adjoint divided by determinant. But so actually how to construct the adjoint. So first you have to calculate the minus, then the coefficients, minus cofactors, then how to get the adjoint out of them, and then after finding the determinant, you need to get the division in between two. So therefore, so we'll do like that. And elementary transformations. So have you done elementary transformations under the basic mathematics? Elementary transformations kara the basic maths. Hello. Right. Anyway, so what do you mean by elementary transformations? Right. So later on, we will perform elementary transformations with different kinds of matrices. So anyway, up to now, so what do you mean by this elementary transformations? The elementary transformations, right? So interchanging any two rows or columns, right? Matrix එකක්. So අපි matrix එකක් ගත්තම මේ matrix එක ඕනම columns දෙකක් මාරු කරනවා. එහෙම නැත්නම් ඕනම rows දෙකක් මාරු කරනවා. මේක කොයි විදියටද affect වෙන්නේ matrix එකට? Right? Right? Changing two columns. Right? Interchanging two columns or interchanging two rows. Right? දෙවනියට තියෙන row එක පළවෙනිට ගන්න, පළවෙනිට තියෙන row එක දෙවෙනිට ගන්න. Right? Interchanging two rows or columns. So how it will affect to the matrix? So that is one elementary transformation, right? So that is one elementary transformation. So then what are the other? Multiplication of elements of any row by a non-zero scalar, right? So here we have a matrix, right? Here we have a matrix. Here what we are going to do is, we get the first row. For example, we get the first row and we multiply the full first row. That means all the three elements of the first row by a scalar. 2 or 3 or 5 or පළවෙනි row එකේ elements ටික ඔක්කොම එක scale එකකින් වැඩි කරන්න යනවා. For example, if it is 3, so then this is 3, 6, 9. So then how it will affect to the matrix? ඒක කොහොමද matrix එකට බලපාන්නේ? So next, addition of constant multiplication of elements of any row to corresponding elements of any other row. So we get a one row. For example, let's say we get the first row and we multiply the full first row by 2. Right? Then this is 2. This is 4. This is 6. And then what we are going to do, we add the first row to the second row. we add the first row to the second row. So then 2, 4, 2 plus 4 means 6. Maybe in the second row. 4 plus 2 means again 6. Right, then 6 plus 5, 11. Right, so now original first row 1, 2, 3. 1, 2, 3. Original third row 3, 4, 2. 3, 4. Now this is the resultant matrix. එතකොට මේ matrix එකේ affect උනේ second row එක. What I did is I multiplied the first row by 2 and add that first row to the second row. Nothing happened to the first row, nothing happened to the third row, but second row is all fully altered. Then how it will affect to A? A වගේ දෙයක් කොහොමද matrix එකට බලපාන්නේ? So the next elementary transformation is, yes, so 3, if a matrix B is obtained from A, right, okay. Right, so those are called the elementary transformations, right? Right, so you may be wondering, so if we multiply only one row of a matrix or one column of a matrix by a scalar, or if we just add 2 rows or columns together, so what is this and how it will affect, and the way how it will affect, you will learn. So when you are learning the properties of the determinants, I'm sure that you have learned the determinant, but so you will learn elementary transformations under the properties of determinant, and also you may learn, you will learn elementary transformations under the properties of eigenvalues, right? So there you will learn how these elementary transformations will affect the matrix, right? So this marks actually the end of the lecture. So here I have covered only the basics of matrices, right? Basics of matrices. From here onwards, you will be gradually learning the important concepts, operations, and some real-world applications coming under the matrices. We'll start the next lecture next week. I'm not going to start a new session because today is the first day. Since this is not the complete new topic for you, because when you are learning complex numbers, that is completely new to you. But here this is not completely new to you because you have already done this part. So therefore, please refresh your mind regarding the basics of the matrices, and so therefore then you will easily grab the other parts as well, right? Okay, so thank you for joining. You can send me the messages of attendance from now on, and I'll upload the lecture notes on the LMS. You can access the lecture notes there. So from today onwards, next week also, you can join with the lecture with the same Zoom link provided to you. Right? So thank you very much for joining. So those who have sent me the messages, you can leave the lecture. Thank you.